A biofilm is an aggregation of bacteria stuck on a surface that contains many metabolically inactive bacteria. In addition to many of them being metabolically inactive, there seems to be some sort of differentiation going on, and communication between bacteria is occurring. This communication is occurring using small molecules. These are called quorum sensing molecules. And we're just starting to discover that there's a whole language of instruction or correspondence going on between the bacteria. Bacteria telling each other to grow faster, to grow slower, to grow less, to attach, to detach. And if we can learn this language, then we can hopefully manipulate the biofilm by talking to the bacteria. We can find out ways to say to the bacteria, detach, or stop growing, or grow slower. And this might be a way of controlling the bacterial infections. So if you start sending signals to detach to all bacterial biofilms, you might end up with more than you bargained for. Probably kill you. So we need a bit more subtlety when it comes to talking to the bacteria. But having said that, there's a lot of companies out there that are patenting these quorum sensing molecules and trying to develop them as possible therapies. Assuming that all infections are caused by biofilms, that the bacteria are actually attaching to a surface, and most of the bacteria are not growing, then the antibiotics are absolutely useless to these bacteria. And at sublethal doses, you may find that the antibiotics are signaling the bacteria to do something. Rather than killing them, the bacteria are picking up a signal and doing something that might be totally opposite to what we want them to do. For example, to look at bacteria, you need to be able to magnify them. You need to be able to see the bacteria and how they interact with the cells. The best way to do this, if you really want to get close up, is with an electron microscope. It gives you better resolution. Of course, we still need all the other imaging modalities, because with the electron microscope, you look at one bacterium or slice through one bacterium inside a cell. It doesn't tell you the whole story, but it can tell you a lot of the story. It tells you where the bacterium is inside the cell. It tells you what membranes are next to the bacteria. So you can see a lot of things with electron microscopes that you couldn't see with light microscopes.